This is CPM Calculus Chapter 5, number 17. So the curves below are pieces of a position versus time graph. Okay, they're two different graphs. This one looks like this one looks like this. For each graph, sketch the graph of the second derivative. Okay, it doesn't say first. Second derivative, and describe what it tells you about the motion. So in order to get the graph of the second derivative, we should do the first, but the first isn't going to be the answer, right? We want to go ahead and sketch the second derivative. So I'm going to do both on top of the current graph, okay? So let's do the first derivative in this light green color, all right? So what is the slope of the function here? It's like 0, right? If you look at the tangent line is positive here, it's growing, it's getting steeper and steeper and steeper and steeper until it gets over here, it's infinity. And so the first derivative, so I'm going to do the first derivative, let's just call that f prime of x is in green, and it's going to go, let me use a better color actually, this is hard to see, I'm going to use dark green, okay? So it's going to go along the lines, right, 0, and it's actually going to look just like the original function. Believe it or not, because it's not a constant rate, so it's going to follow a similar curve to what we're seeing now. Might not be exactly the same, but it's, I can't even get it very well, but it's going to be something similar. Okay, so the first derivative, I'm going to call that f prime of x, is going to look just like the original, right? Because we see it's 0, it's positive, growing, growing, positive, growing up to infinity. Okay, now let's do the second derivative. Let's call that f double prime of x. Okay, now we're going to take the derivative based off our green curve, which was the first derivative. Okay, so again, at the beginning, the slope is 0, right? Then it grows slowly, slowly, gets bigger and bigger until we have a very steep slope, right? Here at the end, the slope is very steep. So it's growing from 0 and growing slowly, but then growing faster and faster and becoming steep. So these are all going to look pretty similar. The first derivative and the second derivative and the original function here are very similar. Okay. Before we go ahead and describe those, let's go on to do the same thing for part B. So let's start off with f prime of x, right? This is different than part A though, because at the beginning here, the slope is very, very big in the positive direction, right? And then the slope gets smaller and smaller and smaller and smaller in the positive direction, right? Still positive, it's just smaller until it gets here and it becomes 0. So unlike the first one that looked just like the original one, this one we're starting at a very high number and going low, 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 low until we get closer to 0. All the time we're positive, right? So let's go ahead and take a look then at the second derivative. Now we're looking at the slope of this one, but now look at it. This original slope is very, very steep, but it's going down. It's in the negative direction. So we're going to start off way over here in the negative direction, steep, so it's negative over here. And then we see that it gets less steep, but it's still going down, so it's still negative until this slope over here approaches 0 as well. So the final f double prime of x is going to look something like this. Okay, it's going to be negative over here, our slope is negative, and over here our slope flattens out and is 0, right? So this starts off very steep in a negative direction, but then goes here and approaches 0 like that. Okay, so again, f double prime of x is in red in both of these. Okay, so let's describe these. Well, if this original function is position versus time, then we know that means f prime of x is our velocity, right? If f of x is position, f prime of x is velocity. So over here we have velocity as well. And double prime, well, the derivative of velocity is acceleration. So f double prime is acceleration. Here we have f double prime of x is acceleration. So let's go ahead and, so right here, the second derivative, sketch the graph of the second derivative and describe what it tells you about the motion. So what this tells me is that the acceleration is increasing, right? This shows that the acceleration is increasing, we know the velocity is increasing and the position is increasing. So for this graph, what does it tell you about the motion of some object? We know that it's position, velocity, and acceleration are all, right? They're all increasing. Okay? Because we know that, again, the second derivative describes acceleration. So that's the first part of the question. The second part is the first part is to graph them. The second part is to say, well, what is that describing? The third is to say what it tells you about the motion. This one tells us, well, it starts off very, very slow. So the position is so slow it's in the negative direction. It's like backing up the car. The car is in reverse and it's reversing at 99 miles per hour. The car is slowing down in the negative direction. It's going from 99 miles per hour in the backwards to 50 miles per hour backwards to 30 miles per hour backwards to 20 miles per hour backwards until it's 0. But all that time is traveling backwards. So this one, it's accelerating. Oh, sorry, the acceleration is backwards. It's accelerating backwards. What does that mean? Well, that means that its actual speed, we know, is in green here, right? That's the velocity. Its speed starts off very high and it's slowing down. It's accelerating backwards means its velocity is decreasing, and the position, though, is still increasing. Okay, so this one over here in part A, its position, velocity, and acceleration are all increasing. In part B, we know the acceleration is backwards, so I would even say, like, how to say that better? I'm going to say the acceleration is increasing, right? It's going from negative infinity to 0. Accelerating, how do you say that? I'm going to say, instead of saying accelerating backwards, I'm going to say negative, accelerating negative, but increasing, right? It's negative acceleration, but it's increasing. And increasing here, we mean getting closer to positive infinity, getting further away from negative infinity down here. Okay? So I'm just explaining backwards a little bit. It's accelerating negatively, but it's increasing. Alright, so that's going to end for us CPM Calculus Chapter 5, number 17.